Welcome to Arizona State University's University Academic Success Programs. This is a topic video for the topic Projectile Motion.
What is a projectile?
A projectile is an object upon which the only force acting is gravity. Once a projectile is dropped or projected, it continues to move by its own inertia and is influenced only by the downward force of gravity. There are certain equations that can be used to solve projectile motion problems. These are the four kinematic equations that can be used to describe an object's motion. We can solve for different values concerning projectile motion by algebraically manipulating these equations. There are also problems involving non-horizontally launched projectiles, where an object is projected at a certain degree above the horizontal. When this occurs, we can use trigonometric functions to determine certain values to be used in the kinematic equations.
Can we try out an example problem?
Definitely. In this problem, a pool ball leaves a 0.6 meter high table with an initial horizontal velocity of 2.4 meters per second, and we are asked to predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing location. Let's draw out a diagram that represents the motion that this projectile will go through. We can begin by organizing the information given and identifying the unknown variables we are solving for. We are given the vertical height of the table, 0.6 meters. The projectile starts at the top of the table, so we can let the initial vertical position of the projectile to be 0.6 meters. The projectile's motion ends when it reaches the floor, which we can assume to have the vertical position of 0 meters. We can assume that the horizontal starting point of the projectile has an initial value of 0. But we do not know the final horizontal position that the projectile will reach before it hits the ground. We are given the initial velocity in the horizontal, or x direction. Because there is no initial vertical velocity defined, we will assume that it is 0. There is only one force acting on the projectile, and that is the force of gravity, which has an acceleration of negative 9.8 meters per second squared. And we do not know the time that it takes for the projectile to reach the ground. We want to first solve for the time that it takes for the projectile to reach the ground, because that information will be used to solve for the second part of the problem. We know the vertical acceleration due to gravity, and the vertical distance that must be traveled in order to reach the ground. Looking at the values we are given, and the variables used in the kinematic equations, we can tell that we will be using this kinematic equation to find the time that it takes for the projectile to reach the ground.
This equation uses the variable x, but the variables we need to use concern the vertical or y direction. Can we still use this equation to solve for the time?
We do not need to use x variables to use this equation. We can substitute in values involving the vertical, or y direction. Doing so, our equation will look like this. Substituting in the numerical values we were given for the variables in this equation, it will now look like this. Now we can use algebraic manipulation to solve for the time it takes for the projectile to reach the ground. Doing so, we find that t is equal to 0.35 seconds.
Okay, so now that we know the time it takes for the projectile to reach the ground, how do we use this information to find the horizontal distance the projectile traveled?
Good question. Remember that the only force acting on the projectile is the force of gravity, which is in the vertical, or y direction. Because there is no force acting on the projectile in the horizontal direction, its horizontal velocity stays constant. We can determine the horizontal distance traveled by the projectile by using this kinematic equation. Substituting in our values for the variables in the equation, we find that the horizontal distance that the projectile traveled is 0.84 meters. Let's try out a problem with a non-horizontally projected object. In this problem, we have a football that is kicked with an initial velocity of 25 meters per second at a 45-degree angle to the horizontal. We are asked to find the time that it takes for the football to reach the ground, the horizontal displacement of the football, and the maximum height that the football reaches. Here is a diagram representing the motion that the projectile will go through. We can begin by organizing the information given and identifying the unknown variables that we are solving for. We know that the initial velocity of the football is 25 meters per second, and we know that the angle at which the projectile is launched is 45 degrees. We can assume that the initial horizontal position of the football is 0, but we do not know the final horizontal position of the football. We can assume that the initial vertical position of the football is 0, but we do not know the value for the peak height of the football. We want to know the initial velocity in the x and y direction so that we can solve for the flight time and the horizontal distance traveled. We can do so by using trigonometric functions. Let's draw out a diagram. Here, we have a triangle where the hypotenuse represents the vector of the initial velocity of the football. We can see that the hypotenuse is at an angle of 45 degrees, the same angle of the football's trajectory. We want to find the values of the two other legs of the triangle, which are equivalent to the initial velocity in the x and y direction. The hypotenuse value multiplied by the cosine of 45 is equal to the initial velocity in the x direction, and the hypotenuse value multiplied by the sine of 45 is equal to the initial velocity in the y direction. We can assume that the final velocity in the x direction is equal to the initial velocity in the x direction, because there is no force acting upon it. We can also assume that the final velocity in the y direction is equal to minus the initial velocity in the y direction, because as we can see from the diagram, the projectile goes through symmetric motion. Now that we have both of these values, we want to find the time that the football spent in the air. We can use this kinematic equation. Solving this equation, we find that the flight time of the football is 3.61 seconds. We can use this information to find the horizontal displacement of the football by using this kinematic equation. Solving this out, we get x equals 63.79 meters. Finally, we can find the maximum height reached by the projectile, which is reached halfway through the football's time in the air. Dividing the time that we found earlier in half, and using this equation, we will find that y2 is equal to 15.9 meters.
Oh, okay. I think I understand this all. But just to be sure, let me go over what I have learned. To solve a projectile motion problem, we will be using the kinematic equations. We want to identify the information that we are given in the problem and the information that we are solving for. We can algebraically manipulate the kinematic equations with our information to solve for the unknown variables. If we are solving non-horizontally launched projectile motion problems, we should use the trigonometric functions to solve for the initial velocity in the x and y direction.
That all sounded right. Now, with just a little bit more practice, this topic can be perfected.